I'm going to tell you, my name is Habib Shamsku. I'm the president of the Advanced Mobility Group. I'm going to tell you a little bit about this panel, that how we're going to conduct ourselves with the 5 wonderful and impressive startup and finalists moving forward while the people are slowly coming to the room. So we have 3 wonderful judges and 5 panelists. First, I'm going to go to the judges that going to ask them a question about how they're going to judge these impressive finalists that we have. Then each one of the candidates are going to get the 5 minutes to present themselves, followed by 5 minutes question and answer. And then at the end of the day, we are going to announce the winner. Best of luck. I know that the pressure is on. So these startup companies, they are really a startup that mostly they've been in the business less than 1 year, and they have a few to 5 to 10 staff, but with the limited amount of the resources and great ambition. So to start with, I want to go first to Paddy Ramanathan from the iValley Finch Accelerator Company, because you are much less known to our audience. I want you to take a few minutes and tell a little bit about the company, and also tell us, in addition to criteria that we have established for them, what else you are going to look for here.
Thank you, Habib. And thank you to Randy, CCTA, and the host of RMS. It's great to be here. I know this is the most exciting part of the day. That's why they have it right after lunch. Hope everyone's doing well. So as Habib said, my name's Paddy Ramanathan. I am part of a corporate fintech accelerator called iValley right here. We have a shared workspace in this building, actually, and we're moving to other parts of the East Bay as well. And I know this is Transportation Mobility Summit, and you're wondering what's FinTech Guy doing here. We work with a lot of startups and also corporates in the financial services area. We run a zero equity accelerator, so we deal with a lot of startups, mostly early stage, but some later stage too. So Randy asked me if I could do the honors of judging today, so I was happy to accept that. In terms of iValley, so we obviously work in fintech. For those who are not familiar with fintech, it's financial services technology. It's a big space. There's almost $100 billion in venture capital investment starting maybe around 2012 when it was getting tracked. So it's grown quite a bit. Obviously started in the US, now is in Europe and Asia in a big way. China is a big fintech player now. It covers the entire gamut. So if you think about Apple Pay and Samsung Pay, that's also fintech. It's not startup, it's big companies. But so it covers the entire gamut from payments, credit. Credit was a big thing, especially when the credit crisis happened back. So a lot of new startups were offering loans or offering things that banks would do. So we kind of track and work with all those kind of companies. Not all of them, but because now there are like thousands of them. Also, obviously, there are incumbents, right? So the banks and the insurance companies. So insurance tech is also a big part. I know Cynthia is in that space. That's a big part, and that's kind of clubbed under fintech, besides payment, wealth tech, credit tech, and there's obviously enterprise technology, which is kind of covers more softwares and technologies that banks use. What I was trying to get at is a lot of the incumbents, they've obviously taken note, not now, but 4 or 5 years ago, that this is a movement, this is a disruption, if you will, that startups are going to eat. I think Jamie Dimon, the JP Morgan CEO, famously said that the fintechs might eat our lunch. So that is true. So the banks have woken up and trying to work with these startups and fintechs in collaborative, synergistic way. So that's where we come in. iValley kind of runs programs for banks, for corporates, in terms of how to engage with startups, what is a risk for them, what is an opportunity for them. So check us out on our website to get more information. I'll be here a little bit in the afternoon if you want to chat a little bit about fintech. Our website is ivalley.co. In terms of what I'm looking for, I'm very excited to hear about the startups. I see a lot of energy. We're local here in the East Bay, so one of the things I'll be looking for in the relevancy of the pitches to the East Bay or Contra Costa County and our problems. And given fintech and insurance tech and any connections to that would be also of areas of interest to me.
Thank you, Paddy. Our next judge is Cynthia Cooper. She's the head of the AAA venture capital, A3V, and you do acquire a few firms per year, so you're at the heart of this business. What is it that you're going to look when you are going to listen to them? Yeah.
Yep. So I do look at venture capital and majority acquisitions as part of A3 Ventures. I head up that team. And we see a lot of venture capital in the transportation space, in particular in mobility as a service and autonomous vehicle technologies. When you look at companies at this stage, one of the key things that I'm going to be looking for is who is your likely first customer, and then how does that affect your scalability? One of the things that we see in the mobility space specifically, and some challenges for early stage startups, is they might have a great technology and then they get an OEM and get really excited about that one OEM, and then don't realize that might actually shut them off to a whole other set of OEMs that potentially could also be benefiting from that technology. So thinking about issues of scalability and really how you can get traction in this very complicated, somewhat siloed transportation market.
Wonderful. Anusha doesn't need any introduction. You heard her impressive speech this morning. How about you, Anusha? What are you going to look for here?
So as an entrepreneur, I know that there are many companies that start and they're great ideas, but not all of them succeed. Many of them fail, not because they were bad ideas, but I think at the heart of a success story, there is a entrepreneur, innovator that is fully passionate and their conviction to make the venture successful. So I will be looking at who are behind these companies and their personal conviction and passion behind the technologies that they're going to pitch.
Awesome. Are you guys ready? Pressure is on. Let's get started. We'll start with the first company, Detectera Incorporation, and Justin and Ryan are here. Please come to the podium, and you have 5 minutes with the hard stop to present your case. So I'm not going to go introduce you further here.
Hi everyone, I'm Justine and this is Ryan, and we're Detectera. Let's see. No. Do we have the green button? There we go. Awesome. So we are passionate about using intelligent robotics to build safety solutions. And our first technology we created and that we're working on is actually an earthquake early warning system. Now, in creating this, it has a very long R&D phase, as I'm sure you can imagine. And as we were going through this process, we ended up developing a bunch of deep learning technologies, working with neural networks, and we came to the realization, wow, this is really applicable to computer vision. And to make a very long story short, we were driving around Los Angeles together and just about got our car stuck in a pothole, and we realized, hang on, this is a problem that computer vision can actually solve. So if you show us somebody who likes potholes, we're going to put a bet on it that that's a mechanic. And actually, here in California, we're keeping our mechanics in business because we have 3 of the worst maintained road networks in the country. And in fact, more critically, 1/3 of fatalities are actually caused by roads in poor condition. So as we think about the future and how can we save lives through autonomous connected solutions. We also want to look at how can we redefine our infrastructure in order to redefine mobility. You may or may not be aware, there's quite a long history of roadworks projects in California, getting funding for them. And now that we have SB1, which goes by many different names, while there is funding available to address these problems, since road issues are still manually reported and manually triaged, it's been quite a difficult process to actually get our roads fixed. I'm sure any of you here in the audience, even driving here, you can see the signs of, this is going to be done X number of years from now, and it doesn't really help you if you're stuck in a pothole now, although it is obviously important to improve our roads. So, to date, the competitive landscape has been really reliant on good Samaritans to make a phone call, click a button in an app, and actually apps that do pothole detection. They're not integrated with anything beyond just their user base. So if you go to Waze and report, hey, that pothole, I almost couldn't get to my destination, that's great, but it only goes to the other users of Waze, and it doesn't enable right now your city, county, state to go and maintain that road unless somebody picks up a phone or uses another method to actually contact those authorities. So our solution is to combine the computer vision technology we developed with machine learning algorithms to create a triage for road maintenance that's based in data and can be updated in real time. So we can connect the video feeds that are available with the GPS signals of where they are. The machine learning system can find those deteriorating road conditions in real time, and we can actually create a triaged list in our website. Excuse me. So when we triage, you would get the dimensions of the pothole, an indication of how important it is to resolve that particular pothole based on where is it in the street, the type of traffic that's affected, etc. And we plan to customize this solution aspect for our individual customers. So our business model is actually relevant to many different potential customers. Not only can we reduce repair costs and increase interagency knowledge flow for agency customers, but also when we talk about autonomous vehicles, we can provide real-time detection that improves the customer experience there. So we've already won 2 of the biggest championships from our alma mater, USC, the MFC Championship and the NVSC Championship. And this year, we developed our image recognition software, and we're going into beta testing. We have a balanced team, and we're very happy to be here with you today. Thank you.
Wonderful, yeah. Great. So, Cynthia, let's start with you. A question for Justin and Brian, yeah.
Sure. Are you collecting the data yourselves, or are you putting your software on cameras that already exist in the car? How do you kind of think through that hardware versus software at this stage of the company?
So at this stage, obviously, we're very, very new into this space. So we have a plan that we're very much willing to innovate based on. But as of today, we're looking at, GoPro actually has a great example of an app where they have the GoPro that people already own, and that GoPro is able to speak to the app and give data. So that's kind of the model we're inspired by, since almost everybody, I think I have a slide about this. I can't get to the, anyway. Essentially, how many people drive around with their phone in their car because they're a rideshare driver, or they need it to know where they're going in general, or people use them with their, yeah.
When you have, if you had an accident, it's forward-facing camera is a nice example. Hello? Thank you. Forward-facing camera is a very nice example, and people use this just to videotape their drives. As Justine said, for What we're looking for is trying to model towards what GoPro does, just add it as an app to your existing phone. That's not to say that's our first, because one of the judges mentioned that question, that's not our first client we're looking for, but that's the way we can actually get enough data to build our own map and understanding of the roads themselves and the dangers within.
Any follow-up? Cynthia, any follow-up?
no,
Okay. So great presentation, great use case, and I'm very excited about what you guys are doing. I know you're early stage, but talk a little bit about kind of financials, right? Who you had a lot of folks who are potentially your partners or customers. So what would they pay? What kind of value, economic value, can you generate for some of them? Don't need specifics, but kind of talk a little bit about what you've thought through already.
Absolutely. We have thought through quite a bit how we're planning to develop our product and make sure that it's sustainable for us and useful to our customers. So most important to that is our plan to do product development that is front-loaded. So we're going to create standard product that we're then going to customize to provide niche solutions for our customers. So during our initial development phase, we've priced our cloud storage at under $30 a month, and we think it's going to cost us about 10 grand to actually write our code. So after that point, once we've had a customer that we're excited about partnering with for our mission, then we'll be able to support their product at a much lower cost.
Anusha. Yes.
When you talked about your competition, you outlined an issue with the fact that they collect information, it's user-based information, is not camera-based, but the issue you pointed out was that that information is isolated in that app and it doesn't get to the authorities. I didn't hear you say how you're solving that problem. Can you elaborate on that?
Absolutely. So for us, we have a couple of different plans for how to solve it, and it's more of a technical question, so I'm going to pass it to Ryan.
Okay, thank you. Okay, so one of the issues is how do we actually get people to care? Because we can go down the trap of what the competitor space shows, which is you need a good Samaritan. And in order for this business to work, we can't rely on good Samaritans. We have to be fully data-driven. So what we're considering right now, is actually having that dash cam portion be what drives this. You build a free dash cam app. It's something you can do as an undergrad in college. It's very straightforward. And the user has that data with the explicit. We will not imply this is explicit. We're using that data for our own collection. So that storage is what we're going to use to be able to tell what the conditions of the road are. Where this consumer gets the benefit is they get to record their video and their drive. Where we get the benefit is we get to build the map with the potholes and the deteriorating road conditions with their help.
And then to finish off the last part of your question, our intention is to make sure that our customers are the ones who are going to be able to use that. So we're excited to find a first partnership. We've had some great conversations based on our initial Detectera technology to partner with a customer who is going to use this for a civic purpose is going to be really key for us to make sure that first customer is using it in a way that is going to promote our technology. That partnership is going to be really key for us.
Great, awesome. I have a 20-second quick yes and no question and answer. Do you have a revenue model, and who is going to be your first customer?
I don't have a revenue model slide, but we do have a revenue model. We're basing ourselves as initiation plus software as a service. So we would charge a fee to set up your niche solution, and then monthly or annually, whatever makes sense for your business. That would be our revenue generation model. And then first customer, do you want to answer? Or do you want to add?
What I wanted to add is we had a number in there for the costs, and it's a very low number. It truly costs us it'll cost $28.95 per month for the data, our storage. This number is strikingly low. It actually comes because one piece Justine didn't mention is we are individually sponsored by Google. Justine is a women tech maker ambassador at Google. And so we have the knowledge that the architecture that we build is really our driver. And to keep the cost low, we know the exact cost per terabyte usage. So we're coming up with actual numbers, not out of the cloud.
Thank you so much. Thank you. And best of luck. Yeah. So next up is Bryce Jameson, who is with the EVC. So he doesn't need much of the introduction. He's going to go through his slides here.
Okay, let's do a little bit of. Yep, everybody can hear me? That's good. Okay, 5 minutes, clock is starting. I'm going to take some of that time at the beginning of 5 minutes to preach to the choir because I think that's the most fun thing to do at the beginning of a presentation. Everybody in this room is probably the best group of people to talk to about autonomous mobility because you come from OEMs, from researchers, from tech backgrounds, from operators, municipalities. If you ask someone in this room, what do you see as autonomous mobility? You're going to get a very different answer than when you ask somebody on the street, what do you see as autonomous mobility? Oh, I'm going to get into my car, and it's going to drive me to work, and then it's going to sit there and wait for me until I have to come home, and it's going to drive me there again. Not quite true. Where do we see in this room the first use cases for autonomous mobility that really make sense? And it's parking lots, it's urban centers, and it's traffic corridors like the 680 and the 101, which I'm all sure we love driving on every day because of the amount of traffic there. Also, you have some institutions. Intersections are really valuable. But we don't need to design a car that can drive anywhere. I don't need a car that can take me to go skiing in the mountains to navigate around a parking lot. And I can have a level 5 autonomous vehicle that doesn't need to be able to drive through a field somewhere because it can drive in any condition in any place. We've got problems that we can solve to get to effective level 5 autonomy in the places where it's needed most before we actually go out and solve the problem of a car that can drive like a person. So how do we make autonomy accessible to the maximum amount of people in the shortest amount of time? So start by looking at what do we need to do to get to autonomy like that. And first, 3D map data. LiDAR maps can be made, but they're expensive processes that go out of date almost immediately. And I'll give you an example because anybody who knows me knows I like to tell stories. I did an autonomous lift at CES this year, driving down the Las Vegas Strip. And halfway through the ride, they said, oh, we've got to take over now because there's construction on the road and our map hasn't been updated to note that. So the car thinks that you're actually just stopped behind somebody who's going to move eventually. And in 10 to 15 months, when they move that crane, the car is ready to go again. Okay, that's fine. Sensor hardware needs to improve. Prediction models need to be developed. And that is, if you're going to drive a car for as long as you need to be 99% sure, you're talking about hundreds of years in fleets. It's a lot of driving to hit all the use conditions. But more importantly than anything, hardware cost needs to come down. Because at the end of the day, it's the user who has to buy this, who says, okay, I've got to buy a new car. Do I really want to spend $20,000 on autonomous hardware to drive to work? I mean, it's one thing to sell it to an early adopter who's absolutely ready. Budget's no option. I can afford a $100,000 car because I love this idea of autonomous driving. But a lot of people are going to say, hey, I really want a sunroof in my car. Do I really want to spend that much money, or do I want to put something that I can use right away? We're talking about OEMs. 7 cents versus 6 cents is something that they actually have large amounts of discussion on. Not, are we going to add $20,000 to the cost of a vehicle? And at the end of the day, what we're doing is we're adding costs, we're adding hardware, and we're adding work to teach a car to drive like a person. When maybe what we need to do is rethink how the cars drive in the first place. So how do we get level 5 autonomy without actually building level 5 autonomy in the vehicle? Start with a ground-based sensing network using the LiDARs and the radars that we've already developed. We use the perception models that have already been developed. But instead of putting it in every vehicle and expecting each car to react individually, let's do what computers are good at. Let's network them. Let's give the ability to the vehicles to see a live 3D map of 3 miles down the road. And the computers on the ground can say to the vehicles, hey, look, there's something coming up ahead. There's a corner that you're going to be going on. There's a blind corner. And there's something around there. You can actually have a local cloud of objects, of hazards, of things nearby that any vehicle, no matter how good they are and how fast the sensor network can see it, you're never going to be able to see something that you can't see. A local cloud of sensors can actually detect things before the vehicle sees it. So instead of teaching a car to drive like a human, let's just adjust the environment. Now, we're running low on time, but what that leads us to is getting away from ADAS to ADAS. So the system in general, same as what you've seen, except instead of on the vehicle, it's off. We're going to build it on sensors. We have processing and control, communications, and depending on the vehicle's ability, so you can use existing vehicles, we can control these vehicles to their ability. So if you have lane keep assist, we can adjust that. If you have forward back where we can do lateral control, we can do longitudinal control. All of this is done from the cloud to the vehicle, depending on the vehicle's abilities. I am absolutely running out of time here, but yeah.
All right,
Let's go to the
you
questions.
can pick it up in question and answer. Let's start with you, Patty.
It's a great idea. So, question: how do you intend to commercialize it? Who would be a buyer? Who would be a customer?
So that's a fantastic question. That's the question that kept me up at night for a long time before I decided to do this. The answer is anybody and anyone. So depending on the level of autonomy of your vehicle, let's say you've got a vehicle with safety braking. Now, if you have a network around that can see everything that's happening, you can send safety braking signals to that vehicle. The vehicle may not be autonomous, but your sensor network can tell that vehicle, hey, something's coming up, you need to stop. It goes through, it comes to the vehicle. Let's say $5 a month on OnStar. You can do it through your existing subscription packages. So you charge the vehicle operators a certain safety fee for safety driving. You can charge the people making the 3D maps. So I don't like the idea of competitors. I'd rather just make the competitors clients. Let's sell the 3D map data to Waymo because maybe Waymo really wants to go out and drive these vehicles with their level 5. They need live mapping and they can send a vehicle out to go and pick up this 3D map, or I can give them a map that they can access that's been updated every millisecond. It's basically take all of the data that you can get from a distributed computing cluster with sensors in a city center where it's needed and sell it to absolutely everyone, depending on their use case.
Great. Anusha?
I love the idea, and I've seen similar concepts. The biggest challenge that everyone faces is because you're talking about these LiDARs and cameras off the vehicle where you don't have control there on city properties or other properties. How do you plan to address right-of-ways and installation, and who will pay for building this network? Because if it's built, it's going to be amazing, but how would you pay for the build-out?
If it's built, it's going to be expensive. That's the other challenge. So the answer to that is, at the beginning, you need to find the right customers who are ready to put in, say, let's say a parking lot operator. You know, my go-to example is Disneyland, because Disneyland has large-scale parking lots where you've got lots of people moving around. You need to have hazard detection in it. But ultimately, where we're going to head is it's a municipality issue. You need to work with the municipalities and the transit agencies to install these systems on the ground. And as I said, it's a really expensive problem. So the challenge is, how do you build a system that over the course of 3 to 5 years first pays for itself to the point that you can transfer all that revenue generation you're getting to the municipality? The goal in the end is to basically allow the municipality to generate its own revenue from autonomy. Because the problem I didn't mention is here more than anywhere except Norway, it's EV world. And EVs don't pay gas taxes. So where are you getting your gas tax revenue from? You either put a fee on vehicles or you find a way to monetize your road infrastructure. So the goal is to come up with a revenue stream that's going to pay for the installation of the hardware within a certain period of time. Afterward, it's a revenue generation model for the municipality.
Cynthia?
Great, thanks. On these vehicle infrastructure type companies, the ones that I've seen have gotten a little bit of traction have identified 1 or 2 key strategic partners.
Yes.
Who do you think your top choices for partnerships would be to get this off the ground?
Well, I think the obvious answer is AAA. But I think the strategic partners, you need to work with a number of different groups. The one partner I would really be looking at is someone like Intel or Ericsson from a network hardware point of view, because there's a lot of challenges in communication, but there's more places where you can generate revenue if you work with somebody like the providers of 5G networks. The second one is going to be a municipality who has a real traffic problem, who is able to reach out to people and say, look, we can license you this hardware that you put in your existing vehicle. It's going to cost you this much a month. We need some place like that, and the Bay Area is a fantastic place to do it. So the 680 corridor, where you can actually go to someone and say, okay, $20 a month, here's your autonomy on the 680. That would be a really great demo project, because those people are there every day and they need a way to get to and from, and it's a local market. Great.
All right, you got some time. Let me ask you a question. How long is going to work with the municipality? So let's say in the perfect world, your product is ready to launch, and then who's going to be your first customer to say that, okay, I want it in my jurisdiction?
I think the first customers are going to be a little bit smaller than municipality level. The first customers could be at the level of business parks, places where you have a certain number of employees, like Bishop Ranch would be a great example. Some place where you have a vehicle that's going to bring somebody here, and it's their private vehicle, but it's got lane keep assist. A Kia Soul will do this. There's companies who already make the remote control option for a Soul that lets you drive with a joystick. So if you can put that into a vehicle at a business park and you give it as an employee benefit that they can say, yeah, we're going to do this, then they can drive straight to the door of the office and let the car go deal with it itself. You don't have to stop and park. You don't need employee shuttles. Just park at the door and let the vehicle handle the problem itself. That's probably going to be the first market that you need to go to.
Thank you very much. Okay, our third finalist is Rod Reports, and Mauro Causi is here to present his case. All yours.
Awesome. Hello, everyone. Super excited to be here. What? All right, we're going to skip the intro slide. My timer hasn't started, just a heads up. Doesn't matter, I'm going to take it. Super excited to be here to tell you about how at Root Reports we're already putting solutions on the road today to solve the problems that are going to enable us to actually accelerate the transition to the future that everyone in this room is excited about. As everyone in this room knows, transport and infrastructure managers are plagued with problems that exist because they're not getting enough data from their assets. Our reports were focused on 3 categories of problems: infrastructure condition, vehicle performance, and passenger experience. Now, think back to how many potholes you had to drive through on the way here, or how many times you've had an unpleasant experience at BART because the train was delayed or there was a fight on that train, right? Those kinds of problems cost the industry $20 billion a year. But there's a more exciting opportunity other than that number. In order to solve these problems, we have to set up the type of data, analytics infrastructure that are gonna allow us to run a fully autonomous society in the future. So how do we do this at Root Reports? Well, we start with the Root Reporter, our custom sensor device. It's a small box, it's about the size of a deck of cards. It can fit onto any train, bus, or van. It can be fitted by anyone in under 10 minutes. It has over 20 sensors inside of it, spits out 400 data points per second, and it has the computational power to run computer vision algorithms, which means that we can tap into any vehicle's CCTV and do on-the-fly CCTV analytics. Now, Root Reporters beam out their data to Root Reports Insights. That's our custom dashboard and analytics platform. Here you see our founder on the right and the manager of operations of Reading buses on the left, looking at their pilot Root Reports dashboard in their control center. So let's walk through some examples of how we're revolutionizing how our clients run their day-to-day operations. In London, Transport for London is running a pilot fitting their buses with Root Reporters so that they can monitor road condition. Now, that means that they can have a high-fidelity map of every crack and pothole on the road. This is the actual data that we're able to beam to Transport for London. This is from an earlier pilot. So the size of the bar represents the size of a pothole, and then the color represents the severity of that pothole, which basically means how much it's going to actually impact the vehicle. So with this, TfL can go and prioritize which potholes to fix, making their operations much more cost-effective. And we can do that with air quality, noise pollution, and many more things. I imagine a future where autonomous road repair vehicles will get this data, go and fix a crack before it causes any damage at all. Moving on to vehicle performance, Stagecoach is running a pilot with us, putting the Root Reporters on their buses to figure out things like, are my doors breaking? Are branches hitting the upper windshield of a double-decker bus, which is going to break that windshield? Funnily enough, AC Transit also has this problem now. So this is what their actual branch's dashboard looks like. We tell them when there's a dangerous branch that should be cut down. We tell them if a windshield has been broken. We send an automatic ticket to their depot so that bus spends as little time out of the streets as possible. And again, we do this with tire pressures, battery voltages, fuel consumption, etc. Stagecoach is particularly interesting because they're running a connected bus initiative, but it only works with a handful of buses that are specially fitted, right? With us, they can retrofit every single bus, and they're basically going to be able to cut down their operational costs in half. Finally, passenger experience. This is all about getting as many people as possible using public transport. How do we do it? Well, we have an extremely effective computer vision system, so we're able to do things like passenger counting, object detection, crime detection, but we are obsessed with eliminating all privacy concerns. So we only spit out text and numbers. We never spit out an image. People are never tracked. This means that we can do things like, if you're a train operator, tell you which routes have more wheelchair users so you can accommodate to them. You can make sure if that your elevators aren't broken. And if you're a passenger, we can tell you, hey, avoid cars 2 and 4 because your bike is not going to fit there. So yeah, business model is very straightforward, $50 to $200 per month per vehicle, depending on the number of features that you're purchasing. And as a customer, you get a return on your investment from day one. We've proven this via our pilots. The company was started by our amazing founder and CEO, Connell. He's in London right now. We're deploying with TfL. He was 17 when he started the company as a side project, basically cooked it up in his bedroom for a couple of years. We officially launched last year. I'm the chief operating officer. Nikita leads our UK operations. And Robert's our amazing commercial director. He has 45 years of industry experience, has sold hundreds of millions of dollars worth of contracts to the same clients that we're targeting today. Wow, I must have gone very fast because I still have a lot of time left. We're really excited to be here, honestly, because on the day-to-day basis, we're focused on solving our clients' short-term problems. But the reason that we're doing this is because we really do believe that it's very important to create a bridge between short-term needs and that long-term vision that everyone in this room is imagining. So that's what we do at reports. We're trying to create that bridge. Thank you very much.
Awesome. Let's start with Anusha this time.
I think it's unfair here on this panel because you're way down the road. You have clients. I love what you're doing. One thing that I'm curious to know is how large is your market? The numbers you shared in terms of per month, per car, especially if you're focused on public transit, seems too low for me. But I'd be curious to know how large you think your target market is.
Yeah, absolutely. So the calculations give us about $32 billion of a total addressable market size that's looking at every bus and every train car in the world. I could definitely follow up with the specifics of those numbers. Those $50 to $200 per month is going to scale up as we offer far more features than what I showed you today. Things like predictive maintenance, for example.
Cynthia.
Could you tell us a little bit more about the product and where your particular point of value is? Is it the relationship with the clients and your ability to sell more into it, or is it the type of data collection? Just a little bit more about the actual moat that you're creating.
Absolutely.
To protect your product.
Well, really, the benefit of having built both the hardware and the software has meant we could deploy extremely fast, right? So I can't tell you exactly who, but we landed in the Bay Area in January, and we already have 2 pilots with leading transport operators here, and that's because it literally takes 10 minutes to plug our box to their vehicles, and it takes us 2 days to customize the dashboard for their particular needs. So it's that mode of our software talking to our hardware, and everybody knows how hard it is to sell to a public bus company, right? When you reduce the friction that much, it gives you a time advantage, essentially.
So I think you answered what I was going to ask, but I saw a picture with a BART image. So is BART one of your pilot customers? Are you working with them?
I can't disclose any of our pilots in California yet, unfortunately.
That's fine. And in terms of the addressable market size and go-to-market, so where are you focusing? Looks like you have some European operations coming to the States. So talk about which geographies, and are you just targeting big cities and public transportation?
Yeah, absolutely. So we're totally focused in UK and California right now. The reason behind that is the company started in the UK, like I said, a year ago. And we wanted to come to California because we want to recruit world-leading clients, right? Talent. So for the next year at least, all of our focus is in those 2 locations.
So where are you based? Where's your engineering operations?
So we're split between London and Berkeley. We have an office in Berkeley and an office. We're a part of an accelerator. And we have a couple people in London.
So do you already have a revenue? Or if not, then when you expect to monetize out of this year?
Yeah, so we've sold pilots. We've sold $42,000 in pilots. Half of that money has actually come into the bank. And all of those have an auto-convert to monthly recurring. Yeah.
Is pilot a public-private partnership, or is all paid by public?
So in the UK, it's actually all private. Because, for example, Transport for London, Stagecoach, all private companies. Here, we're starting to work with public-private. But funnily enough, in the UK, we've also worked with cities, for example, integrating our pothole data directly into the city system so they can go and directly fix the most crucial potholes.
Great. We have 1 more minute if you have more questions that you want to ask him. I have one more. Yeah, go ahead.
So smart cities, right? So a lot of vendors are there. They have their own stack. So how do you play? Have you played with any of them?
No, we actually haven't. Very interesting though, right? I mean, our core advantage versus having to implement sensors everywhere, for example, of course, is that with as little as 10 or 20 vehicles, you can monitor hundreds of miles of road. So that's sort of the value prop that we're thinking of pitching to smart cities type vendors once we begin looking into that.
And in terms of your sensing technology, is that the cost of the unit itself? How much it is? How much is it?
So right now we manufacture them for $100 a pop. Yeah.
Who is your competitor?
Well, we think about it in different terms, right? So technology point of view, Samsara, for example, has very similar technology, but of course not focused on this market. On the other hand, you've got companies like GMV Synchromatics, which offers some slices of the solutions that we have to the same types of clients. When we go talk to our customers, we differentiate ourselves by telling them that with this one small box, they can fix all of their headaches, and they're going to implement it in less than a week.
Cynthia.
Just real quickly, any patents or patents pending?
No, not yet. Honestly, we're just focused on deploying as fast as possible.
Thank you. Thank you so much. Yeah. So next finalist is company Smart Edge. Bhaskar and Kaumi are here to present their case, the future of vehicular computation. Your time starts right now.
So I think it's, again, preaching to the choir, but we're heading rapidly to a world where our cars are all going to be connected, and the level of autonomy is starting to increase. And all of these operations around autonomy require a lot of computation. You get data coming from the car sensors, you get data coming from external sensors, and in the future, perhaps, cars communicating with cars, and really all of this data needs to be processed, needs to be consumed. The average car is on the road 7 to 15 years, but the computation that you put in it is not going to last 15 years. We're all familiar with having to go get the latest computer every 2 years or so. And there's a similar problem that's going to show up in the vehicular domain. So you've got 2 options. You either try to sort of provision upfront a lot of computation in the car, increasing the cost without seeing an immediate return on that investment. Or you ask your customers to come in and change the computers every few years like we change tires. Both of these are going to be expensive propositions. So we estimate that at a minimum, providing a solution that figures out which of the computation is really high priority and must be done on board the vehicle, and what can be moved outside of the car, whether it is to edge computing devices or to the cloud, can result in significant savings, we estimate on the order of 10% or higher over the lifetime of a vehicle, of the vehicle's cost. And the total addressable market for a solution which can provide such management of the data and compute over the lifetime of a vehicle is really quite substantial. So we've been developing at the University of Southern California a number of efforts over the years. Smart Edge is a really a spin-off of that research. It's a decentralized platform as a service solution. It is something that manages the flow of data from the car to edge and cloud computing servers, from external servers, external sensors to the car, or from sensors to compute platforms for different connected and autonomous vehicle applications in an automated manner. And when you have to start talking to third-party vendors' devices on the road, whether it's other cars, whether it's roadside edge devices, or external sensors providing data to you, you also run into this question of why should they share their data? Why should they provide their resources for your computation needs, for your data needs? And so a key piece of our platform is built-in capability for micropayments. And so the platform that we're really putting together is intelligent in that it manages decisions about which computation to run, where, and when, based on the network conditions and the application needs. It is fast. We have algorithms that are optimized for latency minimization and throughput maximization of computation. It is reliable, always ensuring that the most safety-critical applications are never compromised. And it is frictionless in the interactions between the car and other cars or edge and cloud operators that you might interact with. Behind our product is really more than a decade of innovation. We have been working on connected vehicles for close to about 12 years. And the various components that we're putting into this technology range from compute orchestration to blockchain-based frameworks for micropayment and secure and verifiable transactions and computing. The system that we're putting together will also leverage 5G cellular V2X technologies that are just starting to emerge. The partners that we hope to work with in really commercializing this product range all the way from OEMs and suppliers to 5G wireless providers to cloud and edge computing services. And last but not the least, work with government agencies to help monetize the data and the infrastructure that they're starting to deploy for tomorrow's vehicles. We have an outstanding team with many years of academic experience and also industry interactions. We work very closely with companies like GM and Boeing and have had experience working there. I'm an advisor to a standards body called the Mobility Open Blockchain Initiative. And we believe that our expertise in terms of the technology already will bring us quite far. However, we're at a very early stage, and we're really looking for the business and marketing leadership to complement our team. And we're very open to advice on that front as well. So I'll stop with that.
Thank you. Cynthia.
Sure, very interesting. The bringing in the micropayments to some of this is very unique. It's not something I've seen before. A couple of questions. Given that, who do you think your key benefit is being derived for? If you had to think of a stakeholder to help you bring this beyond kind of the research stage, who would be the number one stakeholder that you think has the most to gain?
Sure.
So as you saw in our business model, we have like a lot of people we hope to interact with with this product. I think upfront, the consumer who's like purchasing the vehicle will see immediate benefit in that their investment in the vehicle will last them a longer amount of time. And then obviously, when we're supporting a lot of the autonomous applications that they will benefit from, like autonomous driving assistance and so on, the number of accidents would be reduced and so forth. And I guess we're also providing sort of revenue streams for both the municipality and third-party compute providers. So there's a way for them to sort of invest and make a profit off of this sort of ecosystem we're developing, I guess. Yeah.
So yeah, I like the idea too. It's kind of a combination of a little bit of fintech into transportation. But I want to maybe challenge softly the whole premise. With 5G and more broad bandwidth network being accessed, what is the real compute need in the car that needs to be kind of outsourced, right? Have you looked at that? What are some of the functions and what is the kind of the value there to outsource that?
Right. So I think if you look at today's cars, there's probably not enough computation to derive benefit from this. It's really when you enter the autonomy space and increasing levels of autonomy. So depending on what kinds of sensors are on the car, initially you can provision enough computation to manage the consumption and the processing of that sensor on board. The point is that maybe that's what you start with. You've already got the cars on the road, but all of a sudden you've got other cars on the road that are also doing LiDAR and radar, and all of a sudden you're not just processing the signals from your radar, but these interfering signals from outside. Now you've got additional signal processing to do, and where's the computation that's been provisioned for that? Right? So that's an example of something where the initial provisioning may not suffice for the long-term operation of the vehicle. The other thing you always see in computation, there's a little bit of if you build it, they will come. Once you have the computation, applications emerge, and nobody wants to be left behind in the latest and greatest capability, especially if it's software, you feel like you should have it. But if your computational hardware is preventing you from having those features, you're sort of at a disadvantage. So how do we kind of lower some of that barrier?
I'm curious to know why you picked autonomous vehicles, because you determined there's a 10% computational savings, and if you look at the time horizon of what you're proposing combined with Moore's law cost curve analysis, I don't know if 10% is enough to give you the longevity you need.
Right. So the 10% is already taking into account and factoring into it all of those trends that are likely to emerge. Ultimately, that's a low number. It's sort of a conservative estimate, just something that we are starting out to understand what the size of the market is. Ultimately, especially as we get deeper into the micropayments aspect of it, there's other ways in which we start to realize value. So if the car is generating data, who owns the data? Do they want to be able to provide that data to third parties in order for maybe others to learn from the experiences? There's sort of other channels that might open up that are beyond the pure computation piece of this. But we think that just getting that platform up and running would be a head start on that.
But what I'm curious is why cars and not IoT devices, where you may have a better cost curve analysis and computational.
Absolutely, and as it happens, we didn't really pitch the whole range of possibilities behind the product, but in some sense, our background very much comes from the IoT space, and data monetization and compute capabilities for IoT systems are very much in our mind as well. Absolutely.
So one of the things that always proves a challenge with thinking of autonomy is the increase in complexity that is often added to the vehicles as there's more and more information, there's more and more hardware, and then smart cities. Kind of in the long term, how do you see this technology either exacerbating or helping solve that problem?
So I think the complexity piece of it is going to improve over time when we better understand what the ecosystem looks like, what the different pieces of the puzzle are, and how they should be put together. And the technology we're proposing is the glue that tries to put together these pieces. So if you see the car as something separate, the 5G wireless is something separate, the edge computing is something separate, the cloud computing is something separate, what the city is doing with deploying sensors and actuators and control signals is something separate, you're always stuck in some local optima. Everyone's trying to figure out how to make the next step. So we think platform solutions that help you kind of decouple, but at the same time glue these different pieces together are really the way to try and address that challenge.
And on that, are you standardizing forms of data or other protocols that can help with that interoperability?
So our general approach is to be protocol agnostic, and so build solutions that can work with emerging standards. I think there's going to be standard development happening while we're building this product. And so keep our requirements minimal and flexible so that they can adapt to the standards that are out there.
Thank you so much. Great. Your last but not the least, a Smart City Signal, Jamie Rodriguez and Ty Nguyen. Take it away.
Thank you very much, everybody. Thank you for having us here. My name is Jaime Rodriguez. I'm the founding principal of Traffic Patterns. We're going to be a little unique here amongst the rest of the people competing because we're actually from the transportation world. We spent our entire careers, Ty Nguyen and I, within the public sector, working on transportation projects throughout the Bay Area. And what we typically do at Traffic Patterns, my engineering company, is we consult to all of the people that have just presented before you. We advise them and guide them in building partnerships within the Bay Area and advise them on the development of their technology for use within the public environment. And Ty and I, this is our second adventure together in developing a technology solution, specifically smart city signals. And we both come from that space. If you have a traffic signal in your local agency that was built anytime in the 80s and 90s, you have a traffic signal cabinet that was likely built by this guy that is still running in the field. And it's a testament to how well of a hardware engineer Ty is in that specific space. Peter Schlosser, who isn't here with us, is our software designer within Smart City Signals. And Ty and I really pull our heads together to try and solve the problems that have frustrated us in our careers over the last 25 years, specifically the lack of networking within the traffic signal industry. We estimate that less than 25% of the signals in the world are actually interconnected, specifically here in the US. And that lack of connectivity really comes because it's very expensive to network your traffic signals. There isn't a really good low-cost solution out there or available solutions that are deployable, really until cellular became an effective option for the communities to consider. But because there's a limitation in the network of a number of networked traffic signals, that limits the amount of mobility solutions that can be effectively and quickly deployed within the world. And what I typically hear, because I hear sales pitches all the time for my public sector customers, I see conflict and people wanting to sell solutions to communities that they don't have money for. You know, the money that is there for cities is to be efficient and keep signals or equipment that is in the field running. And trying to build new things with that same money is in conflict with the issue of just maintaining this infrastructure that people already have. So that's what we're trying to solve. And our solution to that is the IoT traffic signal panel. And I'll walk you quickly through what that specific product does. But let me first educate you quickly on how traffic signals work. This is the inside of a standard traffic signal cabinet. These traffic signals take inputs from loop detectors, video detection systems to figure out when cars are there to help assign right-of-way for for green indications, push buttons for pedestrians, and then the controller on that shelf there uses that information to output signals for red, yellow, green, walk, don't walk indications. And that right there is the limit of traffic signal technology since really the 1960s and 1970s. And what our traffic signal panel does is get put into the traffic signal cabinet of any type. If you have a NEMA cabinet, if you have a 300 series type cabinet that runs in your community, we work in any cabinet and we actually read those inputs as they're coming into the traffic signal cabinet. So we're agnostic to the manufacturer of the cabinet and we're agnostic to the manufacturer of the controller. We have no conflict with however these systems currently work within your cabinet. And we use that data and we digitize it to Ethernet and then we send it to the cloud, a cloud platform that we've built called Smart City Signals. And what we want to do today, if we win this competition, we want to use that funding to take it to the next step. We want to implement the mobility solutions that do not exist in the market today. Specifically, we want to use the cloud platform we have to integrate GPS technology from people riding on their bicycles to let those bicyclists in advance, as they're approaching an intersection, put in a green request so they don't have to get off their bike and stop and wait for a green. We want to use that same technology to go ahead and let a bus with maybe a select number of riders that are on the bus get priority to move through an intersection. We want to be able to let rail systems put in those requests. And then our market currently in the Bay Area is focused here in the larger section of the Bay Area. We see a very large market here. Our panel costs $1,500 with $100 a monthly service, and we're actively in deployment in the city of Saratoga. Our specific system, compared to the traditional systems that would cost you hundreds of tens of thousands of dollars to millions of dollars to build, offer you a lot more features, and we want to use that funding to implement the GPS-specific technologies. Normally I would give you a demo, but we don't have time, and so just very quickly what the graphics, very simple graphics look like. You know, the orange, white lines are the pedestrian flashing don't walk activities. The blue dots are loop detection coming in, as well as the active traffic signal displays. But we're thinking beyond traffic signals. We're thinking beyond this one little market sector. We're thinking globally about a smart city. The same panel that we've already built with simple modifications will work in a utility storm or sewer pump station to let cities see that their pump stations are turning on during storm events. And we're actually building a IoT active traffic transportation counter to let people count bicycle on volume and turning vehicle movements at their intersections. And that's actually already built. We just need to finish the software element of it. And if we win, everything will go towards the mobility application side, and we're happy to take any questions.
Great.
Sure. So when can you install in our cities here. So
Tomorrow, but to answer the question.
So your primary customer is the city, or who's your primary customer?
Local agencies are the initial people that we're talking to. We've already got the one active installation. We have 3 planned more installations as demos for hopeful sales before the summertime. But we're also talking to developers. What we find is we consult to a lot of campuses that are building their communities, within cities, and people pay tens of thousands of dollars to millions of dollars to build traffic signals, and they have no idea how those signals are running. So Gilead Sciences specifically, who's a big customer of ours, we've helped them build signals within their community, and they're asking us for this solution so they can actually see what's happening within their community.
Okay. And the smart city providers also do something like that. Are they competitors, or you work with them?
So there's never a competition, there's always synergy is the way that we like to look at things. And so we see people that are trying to do similar opportunities as we're the tool to get them that data. People that have tried to do sales pitches to both Ty and I, they don't have a way to get the data. They're expecting some type of a software agent to be on a server or in the field, and we are independent of that system that does the actual control, so we are agnostic to it. We have full security of the system for the public agency where these things go in.
I'm curious, so you talked about applications that are more consumer, like not getting off your bike to get a green signal. But when you talked about networking traffic signals, I didn't hear much about that part of it, where by networking all of the traffic signals, perhaps you can do traffic management for the entire city and using AI and machine learning. Have you looked at that area and looking at that in the future?
No, thank you. We're actually already doing that. As soon as we deploy in Saratoga, we plan on knocking on the doors of other tech companies to consume our data to help them make their applications be safer. But for the public agency, we're going to give them that ability to monitor and view their system automatically in a non-closed loop environment system. So when an intersection fails today, whether it's a loop got cut, stopped working in the ground, or the intersection kind of went into a flash mode failure, Good Samaritans have to call in and say, hey, I'm not getting a green, or this intersection's been flashing for 3 or 4 days, and then someone gets a phone call, calls a maintenance person, they go out. It's very common to see things fail for months at a time. We actually include intelligence to scan for failed pedestrian push buttons so that we can tell you, hey, go send out a staff person or maintenance person to make the repairs to help the system be efficient.
Now, I'm particularly talking about, for example, traffic solutions where you have congestions and you can actually change the duration of traffic signals to manage a traffic congestion condition.
So the answer is yes. Because we're getting in that detection data, we'll build eventually or find partners to take that information and build more algorithms, more machine learning to figure out, are your traffic signals, are they efficient enough? Do you need to adjust the timing? And then get that information back to the engineers to make the decision, or preferably long-term, build a partnership with the manufacturer of the controller to have that done automatically.
This is a bit of a follow-up question from Patty's question. So who are the incumbents? And are you providing exclusively software, or are you also part of the hardware manufacturing process?
We are both sides, and that's one of the things that really makes us unique. We don't have to find someone to give us the data. We're providing you that tool, if it's for a smart city, for you to collect that data yourself. And then once we have it at the cloud, we can use it to create other partnerships to get that data to be more intelligent in other uses.
And who is the signal provider today?
There's about 5 main manufacturers of traffic signal control equipment within the United States, and they all work differently from each other. That's why it's really important for us to be agnostic to how those manufacturers handle the way they control their signals. And in a lot of ways, we don't touch it today. But with Saratoga, for example, we have extra network capabilities within our hardware. We're going to let the city of Saratoga use our same cellular connection to be able to upload and download timing through a separate system if that's what they choose to do. But when that electrician gets a failure phone call at 3 o'clock in the morning, he's going to get an email and a text message from us along with a note about what the failure was. And the big thing here that I want to point out is the rail reconstruction element. Today, when there's crashes in rail, it's very difficult to see what led to that accident. The reconstruction process is difficult. We scan and track all that data as those requests for rail preemption come in, and we actually can deliver back to the rail agency and the customer the sequence that led to the crashes that occurred in the field, and that's huge for rail records because that's a tool that does not exist today.
So speak a little bit about the reliability and maintainability of your product. It seems to me that your product is most suited for traffic signal company than you directly sell it to the city. If I'm going to open up all of my cabinet and allow you to do this, how I'm assured that it's going to be maintained by you, your staff, your business enterprise that doesn't exist at this time. So I'm just trying to get to the business model. How does it going to work here?
So we're selling direct to the cities because they're the ones that benefit directly from and their communities benefit from that additional operations and maintenance improvements that they get. Sure, long term, we want to build the partnerships with those 5 primary manufacturers of the hardware for the traffic signal industry in the field, because we're that missing add-on piece of intelligence that doesn't exist today. And we're working already on the patents to hold this, for ourselves. So we'll be forcing people to work with us to get that deployed in the future. But we are the guys that understand kind of what's supposed to work. We're the ones that already consult to cities to help guide them towards solutions. And so we felt we were the best people to kind of develop the solution on our own and actually try and sales pitch it at this stage.
Fantastic. Thank you so much.
Thank you.
Yeah. That wraps up our session. We're going to go back in the green room and we're going to huddle and decide that who is going to be the winner. Good luck to every one of you. I want to thank all of our sponsors that make this session possible. Without your sponsorship, we were not able to provide this award. Thank you.